Hi students, let's continue with the classifications of routing protocols in ad-hoc networks. Now coming to the next category, that is a hybrid routing protocols. So far you have seen the reactive protocols, proactive protocols. Now let's see the hybrid routing protocols. Actually, these hybrid routing protocols will have the information, or it's a combination of the reactive and the proactive. So based on the usage. These protocols maintain topology information up to mhops in the tables. So first let's see the disadvantages of reactive and proactive. So those disadvantages will be overcome in these hybrid routing protocols. The disadvantage of reactive is reactive protocols have higher latency in discovering routes. So to discover the routes, the reactive protocols has to be maintain higher latency. And the disadvantage of proactive is the proactive protocols generate a high volume of control messages required for updating local routing tables. So it requires a high volume of control messages, so which are used for updating local routing tables. So proactive disadvantage is high volume of control messages has to be generated, whereas reactive disadvantage is higher latency excuse me, in discovering a routes. So then what this hybrid routing protocol will do? The hybrid routing protocol compromises between proactive and reactive protocol. It's just compromising between reactive and proactive. So how? So let's take a simple example of this hybrid routing protocol, that is a zone routing protocol, ZRP. This protocol uses a combination of proactive and reactive routing protocols. It just takes a combination of both. Okay, taking the combination of both. So what the proactive? The proactive in the neighborhood of our hopes, it's just taking the information regarding the proactive like intra-zone routing protocols, whereas reactive outside this zone means inter-zone routing protocol. So it's just taking the combination of both intra-zone routing protocol and inter-zone routing protocol. This combinedly you can form a zone routing protocol. Okay, so inter means outside, intra means inside. Now let's see, the protocol operates as follows. So how this zone routing protocol will operate? If the destination is within the zone, let us take a different nodes are present. One is a source and another is the destination. Suppose if the destination is within the zone, the source sends packets directly. Okay, so if that node that is present within the zone means within the zone intra-zone routing protocol, then the source can directly send the packet. Suppose if the packet is not within the zone, the destination sends the route request to peripheral nodes. So what it is doing? Suppose the destination is outside. So here the source is here and the destination is somewhere. Okay, source is in one zone and the destination is in another zone. So then what it does? The source will send a route request to the peripherals, means that neighboring nodes. If any peripheral node, that is a neighbor node, has the destination in its zone, it replies with route reply. Okay, so whatever the neighboring node that is present, suppose that node is present in the destination node. So let us take this is one zone and this is another zone. This is a source and this is the destination. Two zones will be there. Inter and intra zones are there. The source is here. Let us take this. Source is somewhere and this is the destination. 10 is the destination. Suppose if the 11 is sending the route request to all the neighboring nodes and 3 is sending the route request to neighboring nodes and the 2 is sending the route request to the neighboring nodes. So if any peripheral node has a destination in its zone, so this is a peripheral node, 9 is a peripheral node of 2 and this is present in its destination zone. So because this is 10 here which is in the destination zone. So whenever you find the node that is present in the destination zone, it replies with the root reply. Okay, it's just sending a message, root reply. I'm in the destination zone, so you're in the correct path. So again, this is sending the root reply, and this is sending the root reply message to the source. Like that, it is sending. Did you understand? So whenever the node is in destination zone, that is the intra zone, so the neighbor, that intermediate node is identifying that is the correct route we are going. So then it replies with the root reply. Suppose if not a peripheral node, simply send the route request nodes to the zone. Suppose it is not in the destination zone, just sending route request to all the neighboring zone. Okay, like that. If multiple route replies are received, the best is chosen based on the sum matrix. So it's generally whenever your multiple route requests. So here this 4 is also sending the route reply because the 9 is present in the destination zone. So this is also sending and this is also sending. So both are sending to the 11 source. So now what this source will do? The source will select the best path. So here only the 2 links are there, and here so many links. So if multiple route replies are received, the best is chosen based on some matrix. So suppose for here this red line, you call it as R is equal to 1, and this orange is the R is equal to 2. For R is equal to 2, the 5, 6, 7, 9 are interior nodes. 5, 6, 7, 9, these 4 are the interior nodes, and the remaining are all the exterior nodes. You call it as a peripheral nodes. So this is a routing within a zone. Topology information is exchanged using route update packets. Thank you.